All right, let's dive right into this explainer. Today, we're doing something a little bit different. We are going to conduct a technological autopsy. Our patient on the operating table, the obsolete but absolutely foundational network hub. By treating this legacy hardware like a deceased technology and examining exactly how it worked and honestly why it ultimately failed, we're going to gain a rock-solid understanding of modern networking and enterprise security.
Here is our roadmap for the autopsy. We're going to cover the original hub, anatomy of a hub, hubs versus modern devices, cybersecurity risks, the SOC Analyst view, and finally, practice and takeaways.
Section 1. The original hub, the foundation of networking. To really understand how we securely connect thousands of computers today, we have to look back at the original, somewhat primitive solution. A network hub operates entirely at layer 1 of the OSI model. That's the physical layer. It deals exclusively with raw electrical signals and bits. Now, the crucial thing to remember here is that it has absolutely zero intelligence. It can't read MAC addresses, it can't read IP addresses, nothing. If an electrical pulse comes into one port, the hub just blindly pushes it out to every other single port.
Think of the hub like a guy standing in a crowded room with a megaphone. If I want to tell a secret to John, I don't whisper it to him. No, I yell it through the megaphone. The entire room hears my secret, even though it was only meant for John. And it gets worse. If someone else tries to use their megaphone at the exact same time I'm using mine, our voices literally crash into each other and nobody understands anything. That right there is the core concept of half-duplex communication, and it's exactly why early networks had such massive efficiency issues.
Section 2. Anatomy of a hub. The internal mechanics.
Let's actually crack the hub open and look at the step-by-step communication process. Imagine PCA wants to send data to PCB. Step 1, PCA generates the frame. Step 2, it sends those electrical signals down the cable. Now pay super close attention to steps 3 and 4. The hub does not read the frame. It just receives the electrical signal, duplicates the voltage, and then blindly broadcasts it out of every single connected port, well, except the one it came from. Finally, in step 5, every single end device receives that data, and the computers themselves have to do the work to figure out if that data was actually meant for them.
So what this means is that a hub essentially forces every connected device to share a single, incredibly congested collision domain. And a collision domain is exactly what it sounds like. It's a zone where electrical signals can literally crash into each other if they're sent simultaneously. Because the hub acts like our guy with the megaphone, everybody is stuck in one massive collision domain and one massive broadcast domain. They are all forced to share the exact same limited bandwidth, which, as you can imagine, creates a massive architectural bottleneck.
Section 3. Hubs versus modern devices, the evolution.
Now, those high-stakes flaws we just talked about, they naturally forced the technology to evolve. Even within the hub family itself, there was a minor step up from passive to active hubs. A passive hub is basically just a dumb physical conduit. An active hub is slightly better because it regenerates and amplifies the electrical signals before blasting them out, which helps the data travel further. But don't let that fool you. Even the active ones were completely blind to MAC addresses. They didn't get smarter, they literally just shouted louder.
When we look at this evolution side by side, the contrast is pretty wild. At layer 1, the hub is completely blind. It offers very low security and just broadcasts everything. But step up to layer 2 and the switch introduces actual intelligence. It reads MAC addresses and actively forwards traffic only to the specific port that actually needs it. Step up to layer 3 and the router reads IP addresses to securely route traffic between entire networks. The hub was just the clumsy, necessary first step that paved the way for switches and routers.
Section 4. Cybersecurity risks. The fatal flaws.
Okay, this brings us to the autopsy's most critical finding. The physical mechanics of the hub didn't just make it slow, they made it a massive security liability. Let me ask you this. Why are hubs considered fundamentally dangerous today? Just think about how they handle data. If a device broadcasts every single piece of information to every single port, what on earth does that mean for network privacy?
Well, from a security standpoint, hubs are basically a nightmare. They're insecure by architectural design. An attacker doesn't have to break some heavy encryption to steal data on a hub network. No, they literally just plug their laptop into an open port, open a network monitoring tool like Wireshark, set their card to promiscuous mode, and just sit back and passively harvest everything. Intercepting packets is trivial because the hub is politely handing the attacker a copy of every single conversation happening on the network. It is the ultimate enabler for a man-in-the-middle attack.
Section 5. The SOC Analyst view.
Hunting ghosts.
Because they're so dangerous, modern enterprises strictly ban them. But sometimes legacy tech haunts modern networks. Picture this. An employee finds an old hub in a storage closet and secretly plugs it into the corporate network just to split a connection for a few extra devices. Suddenly, the SOC dashboard is going to light up. You might start seeing promiscuous mode detection alerts. You will absolutely see unusually high broadcast traffic volumes and a massive spike in network collision logs as that half-duplex megaphone starts wreaking havoc. The whole network segment will experience general performance degradation, and that's going to lead you straight to that unauthorized rogue hub.
And hey, if you're wondering why a SOC analyst couldn't just deploy a quick firewall rule or an access control list directly onto the hub to lock it down, just remember the OSI model. We are at Layer 1. The hub operates entirely as electrical pulses. It can't read packets, it can't read frames, therefore it's physically impossible to implement any security policies directly onto the device itself. It simply lacks the brainpower to be secured.
Section 6. Practice and key takeaways.
Let's turn all this theory into some highly practical takeaways. Because, it's one thing to hear we talk about it, but it's another to actually prove it yourself. If you really want to lock this in, boot up your virtual labs. Build a simple topology in Cisco Packet Tracer using a hub. Fire up Wireshark and capture the broadcasted traffic. Send a ping from PCA to PCB and watch with your own eyes as PCC gets a copy of that exact same ICMP packet. Then swap out the hub for a switch, repeat the experiment, and observe the immediate difference in how the traffic is targeted. Seeing those half-duplex collisions in real time is usually what makes the concept click permanently.
Now let's prep for an interview scenario. This is a classic question. What exactly happens when PCA and PCB attempt to transmit data simultaneously through a hub? Well, the electrical signals physically collide on the wire. The data becomes totally corrupted. The devices detect this collision, and using a protocol called CSMA/CD, they both back off for a random tiny fraction of a millisecond and then attempt to retransmit. This whole chaotic process is the absolute hallmark of a single collision domain.
To make sure you never forget this, lock this cheat sheet memory trick into your brain right now. Hubs equal Layer 1 megaphones. They are blind repeaters, one single collision domain, one single broadcast domain. Just remember the word megaphone, and you'll immediately recall everything about how they operate, how they broadcast data, and why they cause collisions.
We're going to leave our autopsy patient on the table with this final thought. To understand how to secure a modern network, you must first deeply understand the foundational flaws of the primitive devices that built it. By understanding the absolute chaos of the hub, you now know exactly why we so desperately needed intelligence at Layer 2. And that leaves us perfectly energized and ready to explore our next explainer, where we're going to dive into the incredibly smart, traffic-directing world of network switches. Thanks for hanging out with us, and keep learning.